All right, let's take a look at section 7.3. You notice we did skip chapter 5 and chapter 6. We'll actually do chapter 5 and chapter 6 in semester 2. And we also skipped section 7.1 and 7.2. 7.1 and 7.2 are a review of graphing. It's material that we've already covered. So we are just going to go straight to 7.3. All right. So in chapter 7, we're going to be solving what are called systems of equations or systems of linear equations. Okay, remember linear, right? That means we have two variables where x is to the first power and y is to the first power. When we have a system, that means we have two or more, could be more, linear equations with the same variables. Okay, so this, for example, this pair of equations would be called a system of equations. This pair of equations, this pair of equations. You're like, hey, wait a minute, this just has a y, but it doesn't have an x. Well, it technically has a 0 times x, so it has the same variables. Now, when we were working with linear equations before, we had to figure out if an ordered pair was a solution to a linear equation. To do that, we took that ordered pair and we plugged it into the equation. Now we're trying to figure out whether the ordered pair is a solution to the system. So basically, I'm going to clear that. Basically, so we've got two equations, right? And the solution is the point where those two lines cross. Now, with this point where they cross, notice that this point is on this line. It is also on this line. That means it's going to be a solution to this equation, and it's going to be a solution to that equation as well. So when we have to figure out if it is a solution to a system, we have to check it in both equations, this one and this one. A solution of a system of linear equations is an ordered pair that makes both equations true at the same time. A solution of an equation is said to satisfy the equation. All right, so here we go. We're trying to figure out if the ordered pair 4, -1 is a solution to each of these systems. So what we're going to do is we're going to take 4, -1, and we are going to plug it into this first equation. My x is 4, and my y is -1. We're going to simplify it and check to see if it's equal. So we have 20 minus 6, and 20 subtract 6 is 14. And it satisfies the first equation. So it satisfies the first one. Now we have to check it in the second equation. So 2 times 4, we have 8, minus 5, and we have 3 is equal to 3. So it satisfies both, which means yes, it is a solution to that system. Same thing, we're going to take 4, -1, and we're going to plug it in. So we have -4 plus 1, and we combine those. And -3 is equal to -3, so it satisfies the first one. But if you notice, the second equation, 3 is not equal to -3. It does not satisfy the second equation. So no, this is not a solution to this system. All right. Now, if we're trying to figure out where two lines cross, The most visible way of doing that is to draw a graph. So we're going to graph our first equation, we're going to graph our second equation, and we're going to figure out where the two lines cross, and that will be our solution. The set of all ordered pairs that are solutions of a system is a solution set. Graph both. We will do several different methods for solving systems. This is just the first method, and it takes the longest. I'm not going to lie. It takes the longest, but it gives us a picture of what's happening. And sometimes a picture is worth 1,000 words. So we're going to graph both equations, and any intersection point is going to be a solution. The coordinates of any point at which the lines intersect give a solution to the system. Step 1, you're going to graph each equation. Step 2, you're going to find the coordinates of the intersection and check your answer. Now, guys, I understand when you're graphing, it's not exact. It's really hard to graph exactly unless you're using basically a computer. So you're going to give an approximation, basically. So when you check it, it may not check exactly. So just giving you a heads up there, but it should come pretty close. All right, solve the system by graphing. We've got 5x minus 3y is equal to 9. Because this is in standard form, actually, the fastest way to graph this one is to find the x and the y-intercept. So this is going to give me my y-intercept. Remember, you plug in 0 for x, and that gives us our y-intercept. You plug in 0 for y, and that's going to give us our x-intercept. Okay, and the reason we do that, 0 is the easiest number to plug in. So we have 5 times 0 minus 3y. 5 times, or 0 times anything gives me 0. So I have divided by negative 3. I get my y value of negative 3. So I've got 0, negative 3 would be my first intercept, y-intercept. Now I'm going to plug in y equals 0. So 5x, again, anything times 0, and I get 9/5. Now, it's easier to graph when this is a mixed number, actually. So 5 goes into 9 ones with a remainder of 4. So this is 1 4/5. So it's not quite 2. So not quite 2 would put it right about there. And we are going to try our absolute best to get this as exact as we possibly can. Now we have to graph the other equation. I am going to change colors just because it's getting a little bit messy in here. It's hard to figure out which one's which. So let's do, I don't know what color is this. What color is this? So we have y is equal to negative 1/2 x plus 7/2. So this one is in slope-intercept form. Remember, y is equal to mx plus b, and m is my slope, and b is the y part of the y-intercept. So my y-intercept is 0, 7/2. Again, easier to graph if that's a mixed number. So 2 goes into 7, 3, with a remainder of 1. So this is 3.5. So I have my y-intercept at 0, 3.5. 0, 3.5, right there. And then I'm going to go down 1 and to the right 2. So my slope is negative 1/2. So I'm going to go down 1 to the right 2. Remember, it's halfway, so I got to go halfway. So here's my down 1, and then here's my to the right 2. And as closely as I can, do your best to make it as exact as possible. Now, remember, our goal was to solve it. So we're looking for that point where they intersect, which looks like it's about 3, 2 would be the solution to this system. All right, again, I would prefer not to make this video extra long, so I'm going to stop here and pick this up in another video.